Just wanted to do a quick video on this LED bike light that I found today. It's got 3 modes which you change by pressing this little push button on the back. So it has continuously on mode, like a Night Rider style scanning mode, and also a flashing mode. So what I wanted to do was basically just have a quick look inside it and see what makes it tick. So it's got a rubber. The cover just pops off and it has a little rubber O-ring, which I've already taken off. So I'm just going to get the screwdriver on here and I'm going to pop this PCB out. Now you notice it's only got 2 batteries, and that's what I found quite interesting about this, because the forward voltage of these LEDs is probably somewhere in the region of about 2.7 volts, and that means that a freshly charged set of AA batteries is obviously about 3 volts, but it means that when they discharge beyond about 1.4 per cell, it's probably going to stop working, or at least it's going to become extremely dim. So I just want to have a quick look at what's on this PCB first. So we've got let's see if I can focus on that. We have a blobbed chip on board, which is obviously just handles everything. It's obviously a little microcontroller. We've got our LEDs, and we've got 2 contacts on the left hand side here, and we have a PCB switch, which the rubber contacts on the button must make contact with that in order to change modes. So it's very simple. There is no boost converter circuitry or anything like that, which I would have expected to see on account of the fact that it only has 2 batteries. So I'd like to try a quick test, and basically I'll just pop this back on here for a moment, and I'm going to just put this PCB back in, and I want to run it on my bench power supply and just see. No, in fact I won't even put it back in there. I'm just going to. There we go. So it's actually marked positive on the board. So instead of running it on the batteries, I'm going to run it on my bench supply, and I'm just going to clip these clip leads on. You can see we've got a meter here which shows us the voltage we're putting into it. Okay, so it should just be clipped on now, and okay, I'll just have to steal the little rubber button out of it, so I can switch the PCB. Okay, so there we go. So we're now on 3 volts, and I'm just going to set it to the continuously on mode. But now I'm going to start reducing the voltage. Okay, so beyond about, they start losing brightness straight away, and at about 2.5 volts, that probably shows up fairly bright on the camera, but they are absolutely useless. There's hardly any light coming out of them at all. So that is quite a major design flaw, I think, in this, because if you look at the typical discharge graph for a AA battery, let me just go back to Google search now, and I'll just see if I can find a typical discharge curve. Okay, so we can our LEDs cut out at anything under about 2.7 volts, which is 2.7 over 2. Let's have a look. Oops. Try and divide by 0. That was not good. Okay, so yeah, about 1.35 volts per cell, and that is extreme. That is an extremely high cutoff voltage, because if you look at this, so this is about. Imagine here is about 1.35 volts. So we've got all of this capacity down here. Now this is for AA cells, not for AAAs, but it's going to be a pretty similar sort of discharge curve. So we've got all of this capacity left in the battery. So it's only using the first. Well, it's only using the first sort of 30% or so of the battery's capacity. That means that if you actually tried to use this light on your bike, it would it would pretty much, you'd have to be replacing the batteries every 5 minutes, and it's quite dangerous as well because, of course, it would cut out on you on a dark road in the middle of nowhere. But yeah, so I just thought it was kind of interesting, and obviously, I mean, I know why they've done this. They've basically just cheaped out on the design as much as possible. They've made something that works, but it's just not a good design at all. You would expect to have some kind of boost converter circuitry in there, so that it would use all of the battery's capacity, or it would use more of it. It's common really to discharge alkaline cells down to about 0.8 volts, or sometimes even less, and you'd expect it to be able to use most of the battery's capacity really, which this thing can't. So yeah, it's not a particularly expensive lie, but it's not a particularly cheap one either. I think it cost me about a tenner for a set of two. And yeah, I'm a bit shocked really at the quality of that. So yeah, I just thought that would be interesting. Thanks for watching.